Okay, today I'm going to take you through a couple of different things, maybe to help you with your homework, and that predicting products that we were having problems with today. And then I'm going to introduce a new topic at the end. Okay, so whenever we are predicting products, there's kind of a couple steps that we really need to follow. That first step is always to identify the type of reaction. So let's look down here at these types. These are your homework problems, so I'm going to kind of step you through some of them and then most of the way and have you finish them up. Okay? So this is a carbon compound and oxygen. These two mixing together, this is the definition of a combustion reaction. Okay? So we know that the products then are going to be CO2 plus water. Okay? So when we write these products, we have to be really sure that our formulas are correct. Okay? So if you're miswriting these formulas, you're not going to be able to balance your reaction. Okay? And then the third step is to always write the state of matter. So is it a solid? Is it a gas? Is it a liquid? So we know that water, of course, is a liquid. CO2 is a gas. O2 is a gas. And the carbon compound has to be a gas. Okay. So this next one, it has one compound. It's going to break down into its components. So this is going to be a decomposition reaction. Okay, so and most of the time, anytime you have oxygen, these two are going to break apart and hydrogen is going to be produced. Okay, so it would take a ton of energy to get solid aluminum back. So this is going to be aluminum oxide, okay, plus H, hydrogen. Okay, so now we know the type. Now our formulas have to be correct. If you leave it like this, or you were just to carry it over like with H3, because that says 3 over there, it's going to be incorrect. Okay, so we know that H is a diatomic molecule, so it's always going to be H2. Okay, and it is a gas. And then Al, oh, this is an ionic compound. It's positive 3, negative 2. So we're just going to write our charges in here. Okay. Afterwards, this is going to be aqueous. Okay. It'd be really hard to have a decomposition reaction if it was a solid or a gas. Most all the time, it's going to be aqueous. All right. This one we have a compound. We have one single element. This is a single replacement reaction. And so this is when we have to check our chart. Is zinc more reactive than gold? This is a positive ion. This is a positive ion. You can't switch it with that guy. You have to make your formulas look like they make sense. Okay, so if we use our chart here, zinc is more reactive than gold. So we are going to go ahead and, silver. We're going to go ahead and do a single replacement reaction. So now silver is going to be by itself as a solid, and it's going to be zinc nitrate. Okay, so zinc here is a solid. This is aqueous, okay, because you couldn't have a reaction with two solids. Okay, and now he's the aqueous. All right, now we can go back and balance it. Okay, all of these, now we can go back and balance it. So here you have 1Al, here you have 2. So we have to write a 2 out in front. Now you have 3, 6 oxygens. Oops, so I'm going to have to change this guy. Okay, so go back through and balance these. Okay, lithium and oxygen, this is definitely synthesis reaction. Synthesis because we have two elements up front, they're going to combine together. Now, when you have lithium and oxygen, a lot of you just want to write LiO2 to keep it balanced, but lithium is a positive 1. Oxygen is a negative 2. So you're actually going to crisscross these, and you're going to need 2 lithiums to 1 oxygen. So it's Li2O. Okay? And lithium is a solid. This is a gas. Okay, so this is still going to be a solid. It's just going to be oxidized. Okay, now you would want to go through and you're going to need a 2 here for the 2 oxygens, and then you're going to need a 4 for the lithium. Okay, and obviously this big one is a double replacement reaction. Double replacement, they're always going to switch partners, okay, but you have to know the positive and the negative of each one. The positives can't go together and the negatives can't go together. So we're going to have sodium hydroxide. Okay, notice I didn't put the 2 there because sodium is a positive 1, hydroxide is a negative 1, so it's going to be a 1 to 1 there. And then we're going to get calcium phosphate. Okay, calcium is a positive 2, phosphate's a negative 3, so there's going to be a 3 here and a 2 at the end. Okay, and we're going to actually do this one later to show you what the solubility would be in the states of matter. So we'll skip that one for now, and we'll do it in the next slide, or 2 slides. All right, so I want to go over this single replacement reaction. We had our quiz over that today, knowing these top 2. Okay, and basically that is so you just have an idea of those really top reactors. Okay, so now we have to really, again, if this is a positive ion, it's going to switch with the positive ion. You can't have it switch with the negative ion. Okay, so is iron more reactive than calcium? So we come over here. Here's iron, and is calcium above it? Yes. So there's going to be no reaction here. Okay, this one has to be higher than calcium in order to switch places with it. Okay, so let's look at this one now. We have Mn and K. Okay, K is way up here. K is definitely going to kick him out of there. All right, so now we are going to have Mn by himself, which is a solid, plus potassium nitrate. Okay, notice I didn't carry the 3 over because potassium is a positive 1. This is a negative 1. And now you'd have to go through and balance it. So you'd need a 3 here and a 3 here. Okay, so make sure that you can really be able to read this chart, know which one is higher than which. All right, next slide. We're talking about the solubility chart. You're going to be having a quiz over this tomorrow, because tomorrow is Wednesday. So this is dealing with double replacement reactions, and what I'm going to do is I'm just going to give you a list of compounds, and you're going to tell me which ones are soluble, which means aqueous, and which ones are insoluble, which means solids. Okay, so insoluble means it is a solid. Okay, soluble means it can dissolve in water, and that means aqueous. Okay, all right, so this first one, let's look here. Sodium, and we have mercury, chlorine, and nitrate. So they're going to switch. Okay, remember the positives and the negatives have to go together. Okay, so the positive sodium is now going to go with the nitrate. Nitrate's a negative 1, so we're just going to leave it like this. Plus mercury, which in this case is a positive 2, because he's a 2. Okay, and chlorine is a negative 1, so it's going to be Cl2. Okay, so now sodium and nitrate. Let's read up here. Sodium, potassium, and ammonium compounds are soluble in water. Okay, all the time. So this is the top one. So this is going to be what happens most of the time. So this must be aqueous. All right. Your reactants in a double replacement always start out as aqueous. Okay, so that's the easy part. So now silver chloride, if this is a reaction, there probably is a change there. Okay, so let's see if there's anything about silver. And this one says nitrates are also soluble, so you know sodium nitrate is definitely going to be aqueous. Okay, most chlorides are soluble except for those with silver, mercury, lead, and lead chloride is soluble in hot water. So we have lead 2 here. And so since lead is in this, where did it go? Oh, lead, not lead, mercury. Since we have mercury as one of those things that is an exception to it being soluble, would mean that it's insoluble, which would mean that it was a solid. Okay, this bottom one down here, we're going to put the H with the OH, right? Which gives us H2O, okay? Plus BaSO4. Okay, BaSO4, this is obviously a liquid, BaSO4, so barium and sulfate, here's the sulfate. Sulfates are soluble except for with barium, so we know that this is going to be a solid, okay? Alright, let's go ahead and go on to the last slide here. Okay, our last topic of this entire chapter is this idea of net ionic equations. And this is isolating only what is reacting in the reaction. So we can have all this other stuff, but really we want to know what the main reaction that is taking place is. Okay, this only happens in double replacement reactions. So the only time I would ask for a net ionic equation would be in the occurrence of a double replacement. Okay. And in these net ionic equations, you can only separate aqueous solutions. Okay, there's three parts. There's the balanced reaction, there's the complete equation, and then there's the net ionic equation. All right, so let's go ahead and write this out. We're going to have Ba3PO42, which is going to be a solid, plus HNO3, which is going to be aqueous. To get this to balance, let's see, H. Okay, so here I have balanced this for you. Okay, and now what we're going to do is we're going to break it apart into its complete equation. Okay. So we're literally going to take each one of these and break them down into their ions, okay? Only if they're aqueous, okay? And of course, the reactants are always going to be aqueous. Okay, so we are going to have 3 Ba aqueous ions plus, which you put their charge, so it's positive 2. Then we're going to have 3 times 2, so we're going to have 6 NO3 negative aqueous ions plus, this is aqueous so we can split it, we're going to have 6 H positive ions that are aqueous plus 2 PO4 negative 3 ions that are aqueous, forming 3 Ba, so you can only break apart aqueous. See, I started to make a mistake there. So you have to pay attention on which things are solids and aqueous, okay? So this is solid, so it cannot be broken apart because it's only aqueous solution. So this stays the same. So it's Ba3PO4 parenthesis 2 solid plus, here we go, this is aqueous, 6H plus ions that are aqueous plus 6NO3 negative aqueous. Alright, now we cross out spectator ions. So between these two steps right here, you cross out spectator ions. And spectator ions are ions that do not change. Okay, so if we look here, Ba3, you look over here, it changed. 6NO3, it did not change, so we cross them out. 6H did not change, we cross them out. So our net ionic equation then is 3Ba positive 2 aqueous plus 2 PO4 negative 3 aqueous yielded Ba3 PO4 2 solid. And this is your net ionic equation. Okay? We'll be going over more of these in class, and I hope the review helped. Have a great evening.